All right, this is, I guess we can call it part two, right, of section 8.6. What was the thing we did yesterday? Part one. Law, what? Law of sines, right. So we mentioned yesterday that today we're going to do another law. It was supposed to be all in one lesson, but we split it up into two. So what's the other one? Cosines, right. And people always ask me, is there a law of tangents? Well, not that I know of. I don't know of any law of tangents. There is law of sines, law of cosines. So here's law of cosines. There's actually three different ways you could write it. I'm basically sticking with one way, but I'll show you the other two just so if you look at it in the book, you're like, hey, they wrote it like this way. They're really all identical ways to write it, but anyway, you'll see what I'm talking about. Here it goes. It starts off very, very similar to the Pythagorean Theorem. Okay, it's very, very close to Pythagorean Theorem. Now, normally we would say the Pythagorean theorem as a squared plus b squared equals c squared, but I'm going to start with the c first. So let's write Pythagorean theorem. What is it? C squared equals what? Right, a squared plus b squared. Good. All right, but that's not the law of cosines. It doesn't even have cosine in it, does it? All right, but it will in a second. We're going to throw some other stuff in there. So how can you remember the law of cosines? Just remember that it starts off as the Pythagorean theorem. And you're going to have to memorize both of these. You have to memorize the law of sines and the law of cosines. All right, so you're going to have to know these formulas. This is something you have to actually sit down and study. All right, so make sure that you do that. Starts off with like the Pythagorean theorem, and then you tag on a little bit more stuff. So here's the new stuff. Now, I'm not going to show you like how they came up with this. But again, if you really wanted to, which I kind of doubt that you do, but if you really wanted to, you could always go online. Khan Academy, I've seen a couple of videos where he comes up or he proves the law of sines and the law of cosines. He shows where this formula comes from, all right, which is fairly interesting if you're into that kind of stuff. If you're not, probably bore you to death, okay? But it's pretty interesting to see where this comes from. So it's minus 2ab. All right, I still don't see a cosine, but that's where I see one right now. Cosine of, now this is a capital C right here, and this is a lowercase c. So what does this mean? If you're taking the cosine, it has to be a what? It's got to be an angle. And it's not just any old angle, it's the angle that's what to this, it's opposite this side. So this side right, or this C right here is side C, which means it's the side that's opposite this angle, right? It's not just any angle in the whole triangle. It has to be opposite. I'll even write that in there. Okay, this angle has to be opposite this side. That's very, very important. Probably looking at that and say, okay, great. So now I know the law of cosines. I have no idea how to use it. Well, we'll do that in a second. Remember I said there's a couple other ways you could write this? You don't have to have the C out here, all right? Because the A, B, and C just represents three sides of a triangle. It doesn't really matter that that's the longest side or anything like that. It has nothing to do with that. This is just one side of my triangle. This is another side, and this is another side, okay? So it has nothing to do with C has to be the hypotenuse, because remember, these triangles are all non-right triangles anyway, right? So this is not going to be a hypotenuse, because we do this stuff with a non-right triangle. Johnny? All right, if you think of it, let me know. All right, so it doesn't really matter but this angle, what has to be true about this angle? This angle has to be what? Opposite of this side, all right? I don't have to call it C. I mean, I might have letters in my triangle that are called like XYZ or LMN or something like that, right? So it doesn't have to be ABC. It's just representative of that. You could, I normally don't write this, but in the book they write it two different ways. They write it like this. Let's say they made the one side a squared. What do you think the rest of this will be written? If we said this is a squared, how do you think we'll write the rest of this? Yeah, it would be what? B squared plus what? C squared, because this is just the other two sides, right? So if I pick one side right here, I'll call it A, then these are the other two sides. We'll call it B and C. So what's the rest of it going to look like? Minus 2 what? BC, good. Because, right, see this A and that A, this B and that B right there. So these two things that are being multiplied together and times the 2 have to be these two other sides. Do you see that? And then what? Cosine of what? Do we put angle C? Put A. Good. It's angle A because remember, this angle has to be opposite this side right here. So that's another way you could write it. I don't sit here and memorize all three of them. I just memorize the one. All right. Usually it's this one right here. This one right here is the thing that I usually memorize. All right. But just for fun, let's write down another version of this. What would be another version? I got C out here, right? I got A out here, and you could have B out here, B squared. So what would the rest of it be if I put B out here? It's be, yep, A squared plus, oops, C squared minus 2, is it? AC, right? Because it's these two sides right here. It's 2AC, and then the cosine of what? Angle B. So you could write it any of those three ways, couldn't you? The thing I put in a box right here, that's the way I usually have it memorized. And again, you don't have to use A, B, and C. They could be all kinds of different letters. Right? They may not even give you any letters to the triangle at all. They might just say solve for side X or solve for angle X or something like that, and not label anything else. All right, but this stuff still works. Remember, this and this have to be opposite each other. This side has to be opposite this angle. This side right here has to be opposite this angle right here. Does that make sense? All right. Now, let's do an example. All right, enough of that. Let's do an example and see how we actually use this. Oh, by the way, I should have said this. Let's do this first before I show you an example. I'm going to write law of cosines again. Do you remember on the law of sines, we could use the law of sines on certain types of triangles? Remember that? What were some of them? I think there was like 3 or 4, maybe 3, maybe. What was it? Look in your notes if you need to. Angle, angle, side. What was the other one? Angle, side, angle. So 2 angles, right? And then side, side, angle. All right. So on law of sines, you can use that for any of those 3 situations. For the law of cosines, here's the 2 situations that we use if you're going to use the law of cosines. So if you take a look at your triangle, and if you see side, 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 meaning what? Meaning on that triangle, they give you all 3 sides. So if they give you all 3 sides of a triangle, what are you going to use to find one of the angles? Law of cosines. Okay. Or here's another one. Side, angle, side. So what if you have a triangle that has 2 sides and an included angle? Do you see where that angle is? It's in between the 2 sides. So if they give you 2 sides and an angle between those 2 sides, then you're going to use the law of cosines. Everybody with me on that? So that's kind of a nice way to figure out, looking at your triangle, okay, which one am I going to use? Am I going to use the law of sines or am I going to use the law of cosines? You got to look to see what they give you. It all depends. It doesn't matter if it's a acute triangle, an obtuse triangle. It doesn't make any difference. It just matters what information they give you. How many sides they give you, how many angles, which sides, and all that kind of stuff. All right? Now, I think we're ready to do an example. So I'm taking this straight from the book. It's on page 583. So you can just write it down. But if you want to look and see how they do it in the book, I do it just like they do. But you could always look. Now they do label this one ABC. They don't always have to do that, but on this particular one, they do label it angles ABC. All right. Anna, do you have a pass or anything? You're inquire. Okay, gotcha. So that side's 11, that side's 9, and this angle right here is 28 degrees. And they ask you to solve for this. Now they call it X, but if you wanted to, you could call it what? It's opposite this angle C, so you could call this little c, couldn't you? Just to kind of fit our formula, right, that we showed you. Do you want to call it C? Let's do that, since it's a brand new formula. Doesn't make any difference what we call it, does it? All right, we'll just call it C. All right, so here we go. How in the world do I use the law of... Oh, actually, which law do we use? Actually, let's scoot this up a little bit. Does this fit one of these? Does this fit this or this? It's side, angle, side, isn't it? So it's side. I got 2 sides and an angle that's in between those 2 sides. So guess what I'm going to use? I'm going to use the law of cosines. You understand how you know which law you use? Okay. Remember, if you use law of sines, what would you have? You'd have angle, angle, side, side, angle, or side, side, angle. All right, so that would be law of sines. Law of cosines, it's side, 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 angle, side. Got it? Okay. So how in the world do we do this? Let's write our little formula down. C squared equals A squared plus B squared minus 2 AB cosine of C. Do you think that's something that you can memorize? I think so. It's not that bad. It looks a little long, looks a little crazy, but you already know half of it already, don't you? You already know this part. That's the Pythagorean Theorem. Just got to learn this a little bit at the end. If you write it down, and you know what I would do as a suggestion? Every time you do one of these problems, I would write that formula down. I would do that every single time. If you do that enough, you'll have that thing memorized in no time. Okay? It's a little helpful hint to you. Let's see. What are we going to do? Let's plug some stuff in. Let's use a different color here. What are we going to use for this little c? Remember, this little c was originally called x, but I just made it c just to make it a little easier for us. All right? So you use c. All right? So it would just be c squared. I don't know what it is, do I? So I can't put a number in for it. Don't know what it is, so I just call it c. C squared equals. Now, what about the rest of it? What about this a squared and b squared? Yep, could be 11, or it could be 9. It really doesn't make any difference, okay? It could be 11 or 9. Now, technically, it's across from the angle A, so I guess I could call this side A right here. This is opposite angle B, so I could call this side B. But it really doesn't matter. As long as I get the number by itself out here, the other two sides would be your A and a B. And it doesn't matter what order you put it in, all right? I'll put it in this order. Just put them in right there. Okay, so there's my a squared, my b squared, 9 squared plus 11 squared. Let's finish it up. Minus 2. Now, what is this a and b doing? It's multiplying, isn't it? Okay, it's multiplying. So it's going to be 2 times a times b. Where do I get that a and b from? These two numbers right here, right? So these two numbers right here that are doing the multiplication will always be the same as these two numbers right here. Does it really matter what order we put it in? No, it doesn't matter as long as you use those two numbers. Now, what else do we have? We got the minus 2ab. What else do we have to throw in here? The cosine of the angle that's opposite this little c right here, which is 28 degrees. That's not so bad, is it? Just plug and chug, right? Just take the numbers, stick them in the formula. That's all you have to. It's basically all you have to do. That was the easy part. You know what the hardest part about doing this problem is? Putting it into the calculator. That's really the hardest part of doing this problem. Okay? You do it the way that I do it on my calculator, on yours. Yeah. And I'm going to show you both ways. They're actually both fairly close. Let's make this yellow a little brighter. So let's pull the calculator out and let's learn how to do this on the calculator. And this does take practice. And it sounds weird saying, okay, let me show you how to do it on the calculator because you know, you've used a calculator, but you use it for just regular normal stuff. This stuff's a little bit more complicated, so let's make sure we put the numbers in the correct way, and we know how, and you know how your particular calculator actually works. Okay. Let's do it on this calculator, then we'll talk a little bit about the other ones you guys have, that TI-30XA. All right. So let's do this. We're just gonna put all this in straightforward. Notice though, this is c squared, isn't it? All right, so after I put everything in, what do you think I want to do to it to get c by itself? I don't want to square it. I want to do what? Take the square root of it, okay? I could do that right at the beginning, but I'm not going to. I'm just going to put all this stuff in the calculator. Then at the very end, I'm going to take the square root of it. Do you understand why I have to take the square root? Because I'm solving for c, right? I want to find c, not really c squared. So if I want to get rid of that squared, I take the square root. So if you wanted to, you could put a big old square root here, but it just makes it look kind of ugly. So I'm going to put all this stuff in the calculator, take the square root, and hopefully I'll get the right answer for C. Tell you what, see a couple of you punching stuff in already. So go ahead, give it a shot right now. If you got your calculator, punch it in, see what you get, and if you don't get what I get, maybe we'll try to figure out where you went wrong. And if you did get what I got, then you're okay. Resume this. All right, and let's give it a shot. Let's punch it in. So I'm going to go 9 squared plus 11 squared, okay, minus 2 times 9 times 11 cosine 28. So on a calculator like this, it's kind of nice because you just punch it in exactly the way it looks. You get that number right there. But that's c squared though, isn't it? C squared equals that. So what do I have to do with that? Take the square root. So on this calculator, I can go square root of what? Do I have to punch in all those numbers by hand? Nope. I can put the answer. Now, it all depends on what calculator. So that's what this one does. It's got a little answer thing right there. So what is that A and S? That's answer. What is the answer from? This thing right here. So what it's doing is taking the square root of this big number right here. You see that? Hit equals, look at that, 5.2. And that's what C is. Approximately, right? Now, I'm not going to take off if you don't put the little squiggle thing right there, and a lot of times I don't do it, but it is approximately 5.2. It's not exactly 5.2, but it's pretty close. Let's take a look. Does it kind of make sense that it would be 5.2? Yeah. I mean, what if it was like 527 or something like that? You know you'd messed up somewhere, right? Even 27 wouldn't even look right, would it? Because this is 28, which is a relatively small angle, and if this is 11 and 9, there's probably no way that would be 27, right? Because some people might have got to 27 because they forgot to do the square root and said, oh, C equals 27. But you got to look at it, and it's got to kind of make sense to you, wouldn't you think? Yeah, and that does make sense. That's probably one of my smaller angles right there, if not the smallest one. 5.2 is the smallest side, so yeah, it definitely makes sense to me. So make sure you look at it. Just take a second to make sure that it kind of makes sense. What do you think? It's easy, isn't it? Right? Looks complicated, looks crazy, right? If I would have told you you were going to know how to use this thing right here, you probably would have thought, no way, that looks too complicated. But really, once you understand what it means and where to put the numbers in, I don't think it's that bad at all. Do you? Nope. All right. All right, let's do another one. Now, this one's a little bit tough. You're not getting it? Okay, let me give you a hint on how to do it with a TI-30XA. I'll give you a little hint. Actually, let's scooch this down. Here's what I would do. If I was going to use one of the little calculators right there, I wouldn't put all the numbers in like this. What I would do is I would use a parentheses. I think that's very, very important. I would put a parentheses right here, and I'd put a parentheses right here. So what I'm doing is I'm taking this whole thing, I'm grouping it all together, and I'm subtracting it from this stuff. Does that make sense? So go ahead and try it. All right, you ready? You got it cleared? So let's go 9 squared plus 11 squared minus. You get some big number, right? Okay, then put a left parentheses. And then put the rest of it in. 2 times 9 times 11. Try it again. 9 squared. Do it again. Doesn't take long. 9 squared plus 11 squared minus left parentheses. Okay? 2 times 9 times 11. Now, on your little scientific calculator, you have to hit times. Don't hit cosine. Hit what? 28 cosine. Now, if you look at your calculator, you got some decimal number. When you hit the right parentheses, then you'll get this whole thing right here. Everybody see, do you see that? You're not done that yet, because that's just this number right here. Once you hit equals, then what do you get? You get this whole big thing right here. That's probably the 27, right? Once you hit equals. Then you hit square root, and then you'll get your 5.2. Getting it now? All right. So your parentheses are very, very helpful. I could have done that on this calculator right here. I could have put a, in fact, when I taught the other class, I did. I put a left parentheses right here before this 2, and then I closed the whole thing out with a parentheses to be safe, all right? But you got to practice it, okay? You have to know how your calculator works. There's like 3 different calculators in this room, right? Make sure you know which one works or how yours works. And if you're going to take a quiz or a test on this stuff, don't borrow somebody else's calculator that's different than the one that you're using, because then you're going to be all messed up, all right? I mean, maybe you will, maybe you won't. Maybe you'll know how to figure the other one out, but I'd play it safe. Only use the calculator that you've been practicing on. All right, let's do another one. Let's do a triangle when they give you all 3 sides. So write this one down. This one's a little bit more complicated, so if you've been dozing off a little bit, it's time to wake up, snap out of it, and write this stuff down. Because this takes a little bit of algebra. The other one wasn't any algebra whatsoever, was it? Just plugging stuff in a calculator. That's all it was. You stick stuff in a formula, put it in a calculator, bang, you're done. Pretty easy. This one you have to do a little bit of algebra. I'm not even going to label this ABC or anything like that, okay? Because a lot of times they'll just do this. They'll say, they'll give you the triangle, they'll tell you what stuff's equal to, and they'll say, just solve for this one little thing. So in this case, we're solving for angle X. What's different about this one compared to what we did up here? Okay, it's side, 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 but or also what you're solving for, right? What are you solving for on the one I just wrote down? An angle. What did you solve for here? A side. A side, all right? It's a little different. So when you're finding the angle, it's a little bit different. So let's set up the formula, though. Now, I don't even have any A, B, or C's or anything like that in here, do I? But that's okay. What am I going to write down first? The 8. Why the 8? Right, it's not because it's the longest, okay? It's not because it's the longest. All right, it's because it's opposite the angle that we're trying to find. Watch, if I was trying to solve for angle Y, everybody watching this? If I was trying to solve for angle Y, then what number would go first? The 3. Everybody see that? What if I was solving for angle Z? What number would go first? The 6, okay? So since I'm solving for X, the 8 goes first. So it's going to be 8. It's not just going to be an 8, though. What am I going to do to my formula? It's going to be 8 squared. And that's going to equal what? The other two sides squared and added up, right? And it doesn't matter what order you put it in. I'll just go 3 squared plus 6 squared minus 2 times A times B, which is, in this case, what? The 3 and the 6. And then the cosine of the angle that's opposite the 8, which is X. And that's what I'm trying to find. This is a little different. So it's not just a matter of sticking stuff in your calculator right now. What are we going to have to do? We got to get something by itself, don't we? You have to get the X by itself. Oops. Let me just drag this over here. Make it easier to work with. So watch carefully. 3 steps. All right? 3 steps, and we'll get this. Let's just back up in time a little bit. Remember you had stuff like this? You had like 5 equals 2 plus 3x. What if you had something like that? What would you do first to solve for x? Subtract what? Subtract, give me the number. 2, right. Subtract a 2 from both sides, right? Why? Why just subtract it? Because it's being, right, you do the opposite, and what's that 2 doing? It's adding, right? It's a plus 2, agreed? Let's take that simple little algebra 1 problem and let's relate it to what we're doing right here. So what's adding or subtracting? The 3 squared, right? And what else? The 6 squared. So how did we get rid of this 2 up here? We subtracted. So how are we going to get rid of this stuff down here? We subtract. We subtract, right? This is a plus 2. This is a plus 3 squared and a plus 6 squared. So how are we going to get rid of it? We're going to subtract from both sides. Now, I'm not going to do like Algebra 1. Remember you did this stuff like that. Remember that? We're not going to do that now, okay? We know our algebra a little bit better than that. What's going to happen to that 3 squared? It's going to do what? It's going to cancel out, right? What's going to happen to that 6 squared? It's going to cancel out. How did we make them cancel out, though? What did we do? We subtracted. So what do I have to do to the other side? Subtract them as well. Now, some of you guys are going to be tempted to go, oh, 8 squared is 64, 3 squared is 9, 6 squared is 36. Don't do that, all right? I'm just telling you, don't do that. It'll make it easier in the end. So just keep this 8 squared. And what did we do to this side? We subtracted a 3 squared, and we did what? Subtracted a 6 squared. I think this is the very best way. I've seen people do this different ways, and I think this is the best way to do it. See what we did right there? It just canceled out, didn't it? And then I subtracted from both sides. So I took this left side, which was 8 squared. I subtracted 3 squared, and I subtracted 6 squared. We good so far? Well, what else is here? Now watch this. Let's go up here and do the same thing. So what did I have? I went 2 equals what? Yeah, that's right. Why did it put minus 3? Because I was thinking ahead. Because I was thinking what 5 minus 2 is. So that's minus 2. So that would be what? 3 equals what? 3x. Now, what did I do here to get x by itself? I divided by 3, didn't I? So look over here. Same thing, isn't it? What is the negative 2, the 3, and the 6 all doing to this cosine of x? It's multiplying. How do we get rid of it then? We divide. So let's do it. Let's divide by what? Negative 2, 3, and 6. So what's going to happen when I divide this side by those things? Cancel, cancel, cancel. But what do I have to do to the left side? Divide by the same exact stuff, right? So I got rid of these by dividing, so I divide on this side. So it's negative 2, 3, and 6. Look, I got rid of all that mess just in those 2 little simple steps. I subtracted 2 things, and I divided by 3 things. But this all equals what? The cosine of x. We've done this before when we did our trig function. How do I get rid of that cosine? Because I want x by itself, don't I? How do I get rid of that cosine? Take the, give me a good word that we've talked about. Take the inverse, that's the word, okay? Let's take the inverse of the cosine. That'll cancel this out, and what's it going to look like over here? Cosine what? To the negative first. See all that stuff right there? That's what you're going to put in your calculator. Really, you look at it, and it looks confusing, and it looks real hard. Let's break it down, okay? Bit by bit. It's not that hard at all. How did I get rid of these 2 things that were being added? I did what? Subtracted. That's one step. Easy, right? I didn't even do any arithmetic at all. Have I done any arithmetic at all yet? Haven't done anything. All I did was just move everything over to the other side. That's all I've done. Okay? Watch. 3 squared. I subtracted 3 squared and 6 squared. Got that done. Now, this stuff was being multiplied. How did I get rid of that? I divided. So I divided by -2, 3, and 6. Stuck that on the bottom over here. That's all equal to the cosine of x, but how do I get rid of that cosine thing right there? I take the inverse cosine, and it's the inverse cosine of this. Oh, don't get ahead of me. You guys are punching stuff in. Don't do it yet. This is a little bit more complicated. Remember how I used the parentheses? That's what you want to do right here. Okay, it's very, very important. I would do this. I'm going to go 8 squared minus 3 squared minus 6 squared. Okay, then hit equals. Actually, I don't have to, but I always do. All right, you get some, I don't know. Just do 8 squared minus 3 squared minus 6 squared and stop. You won't get an error for that, I promise. Hit equals, then you get some number. What number do you get? 19. Okay. Hit divide. And then, I don't know if you need parentheses or not. We'll try it both ways. But put a left parentheses here. Again, I like to be safe on this. I would put a left parentheses right here. And then put -2 times 3 times 6. And then close that. Parentheses. Once you close the parentheses, that just gives you the bottom. Then you got to hit equals. And that gives you everything. But you're not quite done though, are you? You have to take the inverse cosine of that. So what do? Hit second function cosine. Boom. That's your answer. Let's try it again. I'm seeing faces that are showing me that you're not getting the right answer. Let's try it. Pick up the calculator. Pick it up. Actually, on yours, you might have to hit inverse cosine first. Did you do that? Okay. And then you may need to do this on yours. Put this in parentheses and this in parentheses. All right. So use the parentheses on your calculator. Even if you have a TI-30XA, you can still use all these blue parentheses and it'll still be fine. Okay. But on the 30A, the TI-30 whatever it is, XA, you don't hit the inverse cosine first. If you have that blue calculator, like Carol's got, you're going to have to hit second function cosine first, and then you put all this stuff in. For instance, I'm going to put it all in here. Watch. Second function cosine. So there's the inverse cosine. Now, what do? I put all that stuff on top. I'm going to be careful, and I'm going to put a parentheses there. See that blue one and that blue one? That's that second parentheses. Okay? And so I'm going to put 8 squared. 8 squared minus 3 squared minus 3 squared minus 6 squared right there. Okay, blue parentheses, right? So I put a parentheses right there. See what I did right there? I just put all the stuff that's on the top. Then I hit divide, put another parentheses, put all the stuff on the bottom in its own parentheses. -2 times 3 times 6. Okay, close that one. See what I did? That's the whole bottom, right? I put the whole bottom in a parentheses. And I'm going to put one more parentheses. Why did I do that? Because that's that big orange parentheses. Do you see it? That closed everything in. That's why I put that one right there. Now I hit enter and I should get an answer. There you go. 121 point, we'll say 9. Okay, so 121.9. Let's just, I tell you what, let's round it to the nearest angle. Usually if angles, they ask you for an angle, they ask you for the nearest angle. And let me see, yep, 122 degrees, and that's what x is equal to. Now look, I took a long time explaining this, but it's really not near as hard doing the problem as it is explaining it. What do you think? This is the hardest part right here. It's just getting x by itself. But remember, 3 steps. What did we do? Our first step was subtract these 2. Our second step was to divide these 3. Our third step was to take the inverse cosine. And then you're done. If you do that 2 or 3 or 4 times, it'll be second nature to you. It'll be really simple after you do it a few times. But if all you do is just sit and write down the answers when I read them off to you the next day after you do the homework, you're not going to learn how to do this stuff. All right? If you really want to learn how to do it, you got to put the effort into it. There's no magic formula. Okay? It'd be nice if you take a pill or you can wave a magic wand and say, all right, this is all you got to do. It's so easy to get this. You can just take this pill and you'll be able to understand. No, it doesn't work that way. It takes hard work, right? It's like people that go on diets and they buy this stuff off, they want to lose weight, and they buy this stuff off the TV. They say, oh, lose weight without even trying. You can eat anything you want. Just take this pill and you lose all this weight. That does not work. It doesn't work. Okay? It takes hard work to lose weight. Okay? It takes a lot of willpower. It takes a lot of effort, okay, to lose weight. Same thing with this math stuff. There's no magic formula. There's no, well, just go to this website and you can do math, you know, in 1 hour. You can sit there and you can do all the math in the world. No, it doesn't. It takes an hour every night, okay? At least an hour every night sometimes to be able to do this. You've got to put the effort out, all right? You've got to try. You've got to give some effort. All right, enough of that. I don't know if that'll make a difference or not, but there you go. So now what are we doing? We're finishing up that worksheet, right? So the worksheet was section, what was it, 8-6? And we're now doing 9 through 16. So I want you to do 9 through 16. It's all law of cosines. Okay, they're all law of cosines. Some of them you'll have to solve for a side. That's the easiest one. You just plug stuff in the formula, boom, you get an answer. Now, when you have to solve for the angle, that's this stuff right here. It's recorded. It'll be on YouTube. Watch it. You don't have to listen to every little thing I say on this. You can just skip to the part where you had to solve for the angle if you want to, okay? Just skim through it, find that spot, and just watch that part of it. And try it yourself, okay? Get the book out. They give you a couple examples in there where you can try yourself. Try some odd problems in the book. And you do the odd ones because the answers are in the back. So go to Khan Academy. All right, just do a Google, or not a Google search, but do a YouTube search. Just a general YouTube search, Law of Cosines, and see what comes up. All right, and I'm sure that they'll teach you the same thing. They might teach it easier. They might teach it maybe harder. I don't know. I tell you the truth, I saw somebody else do this the other day, and I did not like how they solved for X. Okay, they made it way too complicated. I like my way. I think my way works really, really well. Give it a shot. Practice it. All right, enough said. All right, so that's due tomorrow, that 9 through 16. And then I'm going to give you a worksheet to work on tomorrow that's going to cover both of them. It'll look just like the one that you got in front of you. But we're going to do both of them tomorrow. I think I'm going to change the lesson plan a little bit. I think I had on Wednesday that we were going to do some problems from the book. But I'm just going to give you another worksheet, okay, instead of stuff from the book. And that'll keep us on track. Okay?